In this video, I am going to discuss the case of gasoline demand and I'm also discussing on various panel analytic regression models. The scheme of presentation is as follows. First, I will discuss the file detail that I will be using regarding the gasoline demand. Then I will discuss a little bit about the model to be estimated. After this, I'll estimate various types of models using stata, and finally, I'll conclude the estimated models. I'll compare the results of the various estimated models. So let me tell you about the file data. In this video, I am using a panel data that is the gasoline document, and it consists of 18 OECD countries over 19 years of time period starting from 1960 to 1978. CO stands for country, YR for year. This is natural log of gas per car, gas consumption per auto car, and this is a logarithm of real per capita income. This is a logarithm of real motor gasoline price. And finally, this is the logarithm of the stock of cars per capita. I am following the same model which was used by Baltagi and Griffin 1980 in their 1983 paper, and this is the functional form of the model. Natural log of gas divided by car is the dependent variable, and natural log of y divided by n, this is the independent variable. Another independent variable is the price of real motor gasoline price, and finally we have stock of cars per capita. So there are three independent variables in this model. Before I conclude, I'll go to stata and I'll estimate the various models. I have already estimated those models. The first model is the OLS, in which I regress log of gas divided by car on log of income per capita, and this is log of real price of motors, and this is a log of car stock per capita. So these are the various statistics. So I'll be comparing these coefficients that I estimated with the OLS regression, and then I will show you this is the panel data regression for the betweens groups, and again I am using the same variables that I just discussed. This is my log gas per car, gas consumption per car. This is dependent variable. This is the real per capita income. This is the real price of motor, and this is the natural log of car per capita, and these are the coefficients. The coefficient with the log of income per capita is positive. This is according to the theory, and with price this is negative. These are actually elasticities, income elasticity and price elasticities. The second one is the command is xtrec, and then the dependent variable and the three independent variable, and this is the within regression, that is also known fixed effect within regression. Again, the sign of the coefficient the same as before, like between. So the algebraic sign for the log of income per capita is positive. This is according to the theory, and with real price of motor this is negative, and also this is negative. And after that I am going to show you the SWAR procedure, that is the random effects GLS regression, in which I am regressing natural log of gas per car, natural log of gas consumption per car, and then natural log of per capita real income, and then natural log of price, real price of motor. This is real price of gasoline, and this is a natural log of car per capita. And after this comma, I have this command RE for random effect, and finally theta. And this procedure is known as SWAR procedure. SWAR basically stands for Swami and Arora. And again, the coefficients are different, but their algebraic sign are the same as before. Finally, I have used the penal regression for the same variables using maximum likelihood estimation with GLS, and these are the various iterations, and below this, these are the coefficients. Again, the coefficient of the natural log of income per capita is positive. The coefficient of natural log of real price of gasoline is negative, and the natural log of car per person, that is also negative. And so basically there are 5 models, that is OLS, between, within, and then the SWAR, and finally the maximum likelihood estimate. My dear follower, you can scroll down these models, and now I would like to compare these models, and I would go to my conclusion in here. And if you look at this conclusion, as I mentioned earlier, this panel consists of annual observations across 18 OECD countries, which covers the period from 1960 to 78. So this is almost 19 years. We estimated the OLS, the within, the between, and 2 GLS estimates for random effect and maximum likelihood estimates, respectively. Bruce, in his paper in 1987, iterative maximum likelihood converged to a global maximum in 4 to 6 iterations, and that is visible in our estimation when we estimated the last model using the maximum likelihood estimation, and that depended on whether one stars from the between or within estimators. For the SWAR procedure, sigma mu hat is equal to 0.196, and sigma nu hat is equal to 0.092, and rho hat is equal to 0.82, and theta hat is 0.89. That can be seen in the estimation that I used in Stata. These estimates for theta are closer to 1 rather than 0, which implies Y feasible GLS is closer to within estimator rather than the OLS estimator. The between and OLS price elasticity estimates of gasoline demand are more than double those for the within and the feasible GLS estimators. Ladies and gentlemen, this was a brief discussion regarding the estimation and interpretation of the gasoline demand of panel data for OECD, for 18 OECD countries, and finally I concluded, I compared the various estimates of the price and income elasticities for the various models. I hope it be of help for you. Thank you for watching this video, and kindly do not forget to subscribe to this channel, and do not forget to click on bell icon so that you can get notification about other videos that I'll upload for you. Thank you for watching this video. See you in another video. Have a good night.